Let's talk about dividing complex numbers. Before we can really talk about dividing, we've got to talk about what are complex conjugates. So let me introduce you to that. If you're dealing with a complex number of a plus bi, remember a is the real number, b and I are the imaginary piece. The conjugate of a plus bi would be a minus bi. Then if you look at the next example, 3 plus 5i, the conjugate of that would be 3 minus 5i. Now in these two examples, what did we change? We changed the sign on the imaginary number. Looking at the third one, the conjugate of 5 minus 7i would become 5 plus 7i. So sometimes it requires that you are starting with a negative and transition to a positive one, and that is okay. This next example could be tricky, but if you remember the rule, all we're doing is changing the sign on the imaginary number. So we are leaving the negative 2, and we will change the sign on 6i, and that is your conjugate. Then 3i, the conjugate of that, all I can do is change the sign. I don't have a real number to even contend with. So negative 3i would be the conjugate. Now, why do we need to talk about complex conjugates? Why are they relevant in this conversation? Well, the reason why is because when we are dividing complex numbers, like this example that you can see, there is an I in the denominator, and that is not good. We don't like those in math. What we want to do is get rid of it, and how we can get rid of it is by dividing these two numbers and then simplifying the fractions. So the first thing I want you to do is zero in on your denominator. It's 7i. What would be the conjugate of that denominator? Well, if we think about that last example we did, all I can do is change the sign on the imaginary part, and it'd be negative 7i. What I want you to do is to always multiply your fraction by the conjugate of the denominator. And you multiply the top and the bottom. When we multiply fractions, we multiply straight across. So let's write that negative 7i first, because it is easier to think about when we get ready to do the next step. And on the bottom, we're just looking at 7i and a negative 7i. What I like to do now is to divide this problem up into two pieces. Let's do a top and a bottom half. We're dealing with a fraction, and fractions are already kind of frustrating for you enough. So let's break this problem down into two manageable pieces, two multiplication problems. That's really all it is. So when we're dividing, all we're really doing is multiplying. Let's distribute here. So that's negative 21i. Distribute again. You will get a positive, be careful here, 28i squared. Remember, I times I is I squared. Now, your negative 21i is good, but this can be fixed, right? So if we replace I squared with negative 1 and multiply it by 28, that's going to become a negative 28. So there is your answer for the top part. All right. Let's go over here to the bottom. Multiply these. So you've got 7i and a negative 7i. All we need to do here is multiply our coefficients. That's negative 49. I times I is I squared. And then we can adjust this, because if we replace I squared with negative 1, it's gone. And that is just going to be a positive 49. So there's your top answer and your bottom answer. So what we need to do is go put those back together and see what we've got. Let's see. Let me give us some extra space here. All right, there we go. All right, my 28 ran away. Let's get it back on there too. It changed it to a, let's see, 28i squared, so that's going to make that a negative 28. Excuse me. All righty. So here we go. On our top part, we have negative 21i. Whoops, minus 28. All of that is over a positive 49. All righty. So we would love for this to be our answer, but actually we can do a little bit more with it because all of those will divide by 7. You are compelled to do that. We always want to reduce everything in lowest terms if possible. So this negative 21, if you divide by 7, will be negative 3i. Divide your negative 28 by 7, it's negative 4. Divide your 49 by 7, it's 7. So, it's all or nothing. All three coefficients or numbers can be divided by the same number. That's great. If not, well, you just got to leave it as it is. Okay, one more example. Try to get through this one pretty quick for you. All right, the first thing you want to do is look at your denominator. It just keeps moving, doesn't it? Let's try that again. All right, so we want to look at the denominator, which is the 4 plus 5i. All right. For some reason, it's not wanting to let me write. Okay, anyway. So we need to figure out what is the conjugate of our denominator. And this time it's 4 plus 5i. So what's the conjugate of that? It's going to be 4 minus 5i. And we want to multiply that on the top and the bottom. Okay, so if we multiply straight across, we're going to have 2 minus 3i and 4 minus 5i. We've done that kind of problem before. And then on the bottom, we have 4 plus 5i and then 4 minus 5i. I know it's looking extremely messy. I apologize. Doing the best I can here. All right, so let's break this up again into top and bottom. And we're going to multiply these two numbers, complex numbers. And then we're going to do the bottom. I'm just going to do b for the bottom. How about that? Okay, now, over here's where most of the work is on the top section. So let's get at it. All right, 2 times 4 is 8. 2 times negative 5i is negative 10i. Then going back to here to distribute this negative 3i through. So that's negative 12i. And then the last two terms will be a positive 15i squared. And we want to clean this up always. All right, so I noticed there's two terms here that are both i's. We want to combine those. And that will be 8 minus 22i. And then here's an I squared. So if we drop it and replace it with negative 1, it changes it to minus or negative 15. Lastly, you can combine these. That'll be a negative 7 minus 22i. So there's your top answer. And let's see what happens on the bottom. That'll be a 16, negative 12i. Oh, excuse me, that's a 5, Miss Brown. So that's negative 20i. Sorry about that. Let's start over. 16 minus 20i plus 20i. And then minus 25i squared. All right, now what you should notice about this is that these two middle terms, the i's are canceling. That's good. That means the I is gone. And it's about to be because now I've got this thing at 16 and a negative 25 squared becomes a positive 25. And when you add those together, you get 41. And all of these numbers are just going to have to stay how they are because there is not a common factor that divides into 7, 22, and 41. I hope this helps. Please shoot me an email if you need anything.